All right, so we're looking at the absolute value inequalities. And remember, absolute value is a measure of distance or how far you are from something, right? So think about this in the context of you have the absolute value of x is greater than or equal to 5, right? That means our numbers are going to be greater than or equal to 5. So a square bracket, and we're shading up, right? Or at -5, we have a square bracket and we're shading down. If you think about this in terms of a compound inequality, this means x is less than or equal to -5, or x is greater than or equal to 5. So that's what we get when we have an absolute value inequality with greater than or equal to. Now, absolute value of x is less than or equal to 8, right? Think about this as going towards 0. We're going near 0, right? X is going lower. So x is less than or equal to 8. So I'm going to put a square bracket at 8 or a closed circle, and at -8, and we're shading between. Right, so our compound inequality equivalent to the absolute value of x less than or equal to 8 will be -8 is less than or equal to x, which is less than or equal to 8. So that means the same thing as our original absolute value inequality. So what this means is absolute value inequalities they're really just compound inequalities. Okay, whenever we're talking about greater than or equal to, right, we can think about we're going up, right? We have or, and if we're talking about less than or equal to, we're going towards 0. We're talking about and. So go ahead and pause the video and try those number 1 and 2 at the top, and then we'll do it together. All right, so number 1, you have absolute value of x is greater than or equal to 4, right? Greater than or equal to 4. We're going away from 0. So we have a square bracket at 4, shaded to the right, a square bracket at -4, and we're shading to the left. In other words, we're saying x is less than or equal to -4, or x is greater than or equal to +4. So the integral notation for this is in 2 parts. We have -infinity, comma, -4 square bracket, and then our union square bracket 4, comma, infinity. All right, now for number 2, we have the absolute value of y is less than 7. So we will be going towards 0. So we have a parenthesis at 7 or an open circle, a parenthesis at -7 or an open circle, and we're shaded between, right? Remember, this absolute value inequality is the compound inequality. -7 is less than y, which is less than 7. So our integral notation will be from -7 to 7 inside the parentheses. Okay, now our next 2 examples here, a little tricky. So let's do the first one. Number 3, we have the absolute value of x is greater than -1. So from before we saw what happens when we're saying greater than -1. How do you go away from 0 and to start near -1, right? We're greater than -1, right? What's the other part of that? Or x is less than +1. So how does that happen? Let's show the parts separately first. Greater than -1. We're going large and away from 0. So how do we go large? We go up. Now what about less than 1? So we would go at 1, we go down. So now what happens here? We have to combine those two and we end up with the entire number line. So that one can be a little bit tricky. You want to just take it piece by piece. Now our interval notation, -infinity to infinity. All right, number 4. So this one a little tricky as well. The absolute value of x is less than 0. Right now, let's think about what this means as a compound inequality. It will be x is less than 0, but also, and it's also greater than 0. Well, how is that? That's impossible. Impossible. So this is an example where you have no solution. All right. Now we're looking at some examples where we're going to solve, right? So we have the absolute value of x minus 1 is greater than 6. So this means two things. X minus 1 is greater than 6, or x minus 1 is less than -6. Okay, so now from here, I'm going to add 1 to each side. So I get x is greater than 7, or can add 1 to each side for the second part. And we have x is less than -5. All right, so now graphically this means, so we have a parenthesis at -5, or open circle and we're shading down, or a parenthesis at 7, or an open circle and we're shading up. So interval notation, we have -infinity to -5, parenthesis, and then union. Then we have 7 to infinity. And let me just break that down a little bit in case we need a review for interval notation. Remember, you're going from left to right. So whenever I see this arrow going infinitely in one direction, I know this is -infinity. And then it goes up to -5. So that's my first part of my interval. Then the second part of the graph starts at 7, that's the left, and it goes up to infinity. So that's the second part of my interval. Okay, let's pause the video, go ahead and try this one on the right. All right, so we have the absolute value of x plus 2 is less than or equal to 7. Remember what that means as a compound inequality. It is x plus 2 is less than or equal to 7, or greater than or equal to -7. So now from here, I can solve this by subtracting 2 from the middle. So then I subtract 2 from the right and the left. And that gives me -9 is less than or equal to x, which is less than or equal to 5. Okay, so these numbers are going towards 0. So I'm going to put a square bracket at -9 and a square bracket at 5 and shading between. And so my interval for this, okay, again, if you want to break this down into the little parts, you go from left to right, and there's only one part to the graph, so you should only have one interval. So we have here, this is -9. On the right, we have 5, and I'm using square brackets. So square bracket, -9, comma, 5. Okay, we have 2 examples here. Go ahead and try them on your own. Pause the video, and then we'll do them together. Okay, so the first example here, we have the absolute value of 3x is greater than 12. The analogous compound inequalities are 3x is greater than 12, or 3x is less than -12. So now I'm going to divide 3 on each side for both of these. So we have x is greater than 4, or x is less than -4. Okay, so our graphs, we go greater than 4. So you can use a parenthesis. You can also use an open circle if you prefer that. If I use the open circle and I shade to the right, that's the same as the parenthesis. And if I use an open circle and shade to the left, that's the same as the parenthesis. All right, so our interval notation, remember what you have here. You have -infinity to -4. And here you have 4 to infinity. So our parts go. Parenthesis always for infinity. So parenthesis, -infinity, comma, and then -4. Parenthesis whenever you have an open circle. Union. Parenthesis, 4, comma, infinity. Parenthesis. Okay, now for our second part, we have the absolute value of 2x plus 5 is greater than or equal to 3. Again, since it's greater than or equal to, we're going away, we're going large. So we're dealing with our compound inequality or. So we have 2x plus 5 is greater than or equal to 3, or 2x plus 5 is less than or equal to -3. You always flip that symbol when you do the negative portion. Okay, let's solve. Subtract 5 on each side, and you do it to both of these. So the first one, we get 2x is greater than or equal to -2, or 2x is less than or equal to -8. Then we're dividing by 2 on each side. So we have x is greater than or equal to -1, or x is less than or equal to -4. Okay, so let's put this on our graph. If I say greater than or equal to -1, you can use a square bracket or a closed circle and shade to the right. Less than or equal to -4, again, you can use a square bracket or a closed circle and shade to the left. So the different parts here, this is -infinity. This endpoint is -4. The next endpoint is -1 to infinity. So we write parentheses, always for infinity. -infinity, comma, -4. Square bracket, because we have a closed circle. Union. Square bracket, -1. comma, infinity, close with the parenthesis.